Welcome back to the channel. Today we are going hands-on with the ITECH IT6700 Programmable DC power supply, a compact switching mode unit that promises precise control, low ripple and plenty of power for your electronics bench. This is ITECH's first collaboration with the channel and I'm curious to see what they sent. I'll put it through some tests to see just how well it performs, measure its accuracy, put it under some load and see if it is as good as the specs suggest. And talking about that, this unit was sent to me free of charge for review, but as always that won't influence my testing or the conclusions. You'll get my honest opinion, the good and the bad. As a disclaimer, no money was exchanged to produce this review and they will see at the same time you will when it's published on YouTube. And if you find this review useful and want to support and be a channel sponsor, please consider using the affiliate access links shown on the screen or in the video description whenever you need to do your purchases on AliExpress or Amazon. It won't cost you anything extra, but it helps me keep making in-depth test equipment reviews. So let's get into it, and I will start by the IT6700 key features. Allow me this small break to send kudos to this video sponsor, PCBWay. Being a leader in PCB fabrication, it is able to manufacture with very low price and in record time the PCBs for your project. Don't believe me? Just take a look. You get 10 PCBs double-sided for $5. It's hard to beat this. But that's not all. You can even create your project parts like custom case with their injection mold service or 3D printing, not to talk about their professional CNC machining service. It's a one-stop supplier for all your project needs, and if you use the code below on the screen, you will get a $5 discount on your first order. As usual, let's see what is delivered in the box. It is packed in this box, nothing special, but what matters is what comes inside. Let's open it. Okay, and for starters we have a power cable. This doesn't seem to be the cable for Europe, but let me check. No, not at all. Okay, doesn't matter, I have plenty. And we have a USB cable adapter, it seems. Yes, serial to USB cable type B. And this is from ITECH also. And the normal USB type A to USB type B cable for connecting to the power supply. And let's see what we have in here. Okay, some documentation. This is, okay, let me take the box out. So this is a calibration certificate. It is always good to see one of these on test equipment. The date is 23 of June of 2025, so this was recently calibrated, and we have some more information in it. This should be a user manual or quick guide. ITECH products downloads. Okay, in several languages. Very nice. Let's put it here. Let's take the unit out of the bag. It comes in this bag zip pocket. Okay, here we have it. Okay, so this is a very basic unit. Sometimes you don't need more than this. The buttons are okay to the touch, clicky. They seems to be silicone. We have the power on the front. That is good news, very good news. And we have the standard size for the connectors, the positive and negative, and the earth connector is on the right side. This is very useful. For example, you can use these adapters for connecting to an oscilloscope or whatever. And these connectors are those that you can connect directly in here with that crab connector thingy, or directly on the front with a normal banana type cable. So very nice. Some brands like Owen put the earth in the middle, and this is not very useful since you will not be able to use these kind of adapters for measuring the ripple or whatever. Anyway, you can use a banana plug with the adapter, other kind of adapters, but this is more efficient. Okay, other than this, the knobs, it works okay, but yeah, this could be improved in the future. Okay, other than that, we have a serial connector in the back, a fan for ventilation, and the voltage selector for 110 or 220. We have here the sticker, it is already at 220, and we have also here a socket for the fuse. Other than this, nothing else special. I should say that having the power button in the front, and it is a mechanical power button, is pretty awesome. This might not seem important, but if you have this on your shelf and you want to power on the unit, you will have, for example, in this oven, to come here in the bottom and power it off. If it is in a shelf like the ones I have in there, that might be a bit difficult. So you have to take the unit out to put it here. In the front is always easier, and it seems to be the ideal position to have it. Okay, let's now power this on and see how it works. Everything is ready. Let's start by powering the power supply. Okay, it has very nice letters. It's not a LCD, that's a pity, but it reads very well the letters on the display. Okay, in terms of what we have in here, we have 4 preset channels, but that's not all. These positions can be also used for aligning the value, but I will show you this. We have the light for the constant voltage, constant current, OVP, OCP, lock, and the program when we have the channel off, and the switch. For the switch, we have this blue button. When pressed, the light will power on, and then you have these blue letters also that are options that you can use. For example, for the lock, you just press the blue key, we are with shift, and can press lock. And right now everything is locked, you cannot do anything. Okay, so let's press again the shift locked to unlock it. We have also other options like save program, other than the lock, the setup, and obviously the display also here. So for the display, you just press the shift and shift again, and it will show you what is the current voltage selected. Each key has several functions, as you can see. A, B, C, and D will select the pre-programmed channel, the preset, and you have also the direction keys in here, the selection, and this will allow you to exchange between voltage and amperage or between tension and current for selecting the values. One thing that I do not appreciate a lot is that the selected voltage and amperage is not always on the screen. You have to do this with the display or move the cursor. While working with it, it will show what is outputting in terms of the voltage and amperage, but right now you cannot see what is the voltage that is preset. And for me this is a bit annoying. Okay, you can change, for example, the voltage. I will leave it at 5 volts, and then you can select the amperage and change it from, let's take this a bit faster. Okay. To 1 milliamp, and that's it. But this will not show on the screen. I understand that we have only 2 number displays, so they have to manage that. but for working I would prefer to have it always on the screen. You can also set the OVP and OCP. Let's do that. For that you just press Shift and press the VA for 3 seconds. Okay, and this will start this menu, and for this menu you can use the knob to change the OVP. Okay, if you want to do it faster, just use the cursors to put these little LEDs in the position of the digit you want to change. For example, if I leave this here, and now it will be faster to let it go up to 1 volt. So I will set the OVP at 60 volts, and if you press this return key, it will allow you to set the OCP also. It is at a maximum that is possible to output with the power supply in terms of amps, but you can change it obviously. And that's how you set the OCP. If you continue to press this return key, you will see the other options that you can set up, like the memory set for the power status setting. This will allow you to store the configuration that you had the last time you worked with it, and when you power on, it will show you the same values like the voltage selected and the amperage and so on. Continuing, you have the power output state. This will allow you to configure if the power state, when you power off the power supply, it's so many powers, it will be saved or not. In this case, it will not. If you want to change it, just use the knob. I didn't mention before, but that's how you change it. And if you continue, we will have the option to turn off the beep. I like to have beep in these things, but this one is quite loud, so I will power it off. And also we have the power address. I thought that I disconnected the beep. In terms of the power address setting, I believe this will be used when you have several units to understand which unit you are addressing, but I'm not sure right now, to be honest. And the manual is not also very specific about this. But let's move on. And after the power address, you have also a group of shortcut keys. You can select it like this, A, B, C, or D, and change here. And I think that we are almost done. Yeah, that's it. Okay, that's how you set the OVP, OCP, and a few other components. Right now we don't have the beep, but somehow I miss it. It's loud, but I will keep it. I prefer to have this annoying beep. Sorry if it's not your opinion. It will be nice to have a lower beep, but I like to have the beep while working. Okay, so let's do this, and yeah, we are back to normal. While the user manual is not really clear how to use the memories, I believe I got it. So we press Shift and go to Prog, and then select the memory. For example, A. We have 6 volts at 7.1 amperes. At this time, if you open the channel, it will show you that it's outputting 6 volts. If you want to change it, for example, let's see how we will do that. Display? No. Okay, we are on A, and this is a bit annoying because right now I'm not sure how we will change the program. Let's press it for a while. Okay, prog. So we are on B. Okay, let's see again. So we are setting the voltage like 5 volts. Okay, and in terms of amperage, I want to, this is too slow, let's take it to 0, and then 1 amp. Okay, then I want to save it on A. I believe that's it. Okay, and if I power on, yeah, that's it. Okay, it's not hard, you just need to understand how to do it. So let's try again. I have the channel open. Okay, let me try to set this to, well, 12 volts. Okay, it's a normal, okay, 12 volts and 2 amps. Okay, and I want to save this on B. Okay, if I start now, it will be with the memory. Okay, let me get program, and I want A again and open. Yeah, that seems easy after you got the hang of it. And basically I think that we are there in terms of the usage. So we have one last thing, if you didn't get it before, is that let me try to open the channel. Yeah, it's open. If you want to change this faster, the digits, I am still in prog modes. Okay, how do I get out of it? Okay, now I am out. So if you want to change the digits faster, you have this indicator on the top that is also the place of the presets. And when you use the direction keys, you will be able to change the digits on the location of the LED. Okay, and this will be nice to move faster or slower with more precision the values. On the top you can only go up to the B, it will not go to the A, but you are able to in the same way to change the digits. And that's it in terms of the operation. To test the accuracy of the power supply, I got here an angle where I managed to put everything on the screen. Let's see if I can show you this working as it should. To start, I will use my SDM3045X from Siglent. That is the multimeter that I used in basically every review I made on the channel. But I have today a pile of multimeters here to test it in several cases. So on the right side of the Siglent, we have the 34461A 6.5 digits multimeter. And below we have the oldie that I normally don't use, just I use it more to make sure that everything is accurate in terms of the devices I use. But we have also the 3457A, it's a Packard from the old days, and this is a 7.5 digits multimeter. So I will start with a very low voltage, like 10 millivolts. Yeah, I think that's it. Let's start and see what we have on the Siglent. So on the Siglent we have 10.5. It is oscillating a bit in the power supply also, so let's see what we have on the key site. Okay, let's put it here. And on key site we have 10.7, it's more or less 10.5, more or less the same. And on the Packard it says also 10.5. So the voltage seems very accurate. Let's take this to 1 volt. Okay, let me see. Yeah, 1 volt. So in terms of 1 volt, we have 0.999 something, almost 1 volt in the Packard. On the key site we have 0.9997, also 67. So this seems very accurate. All the devices are basically giving the same voltage. Let me just try here. So we have 0.999767. It seems very accurate at 1 volt. Let's take it to 5 volts. Okay. 4.9975 on the Siglant, and on Keysight we have 4.5, spot on 5, yeah, very good, very good. Okay, and on the Hewlett Packard also at 5, very good. Only the less significant digit is oscillating a bit, but very nice in here. Okay, let's take it to 10 volts. 10 volts also basically a spot on. Very accurate. And on the Keysight 10.001, it's a slight difference, nothing serious. And on this one, on the Siglant, we have 0.9997. Okay, very near also. I can connect several cables at the same time, but to avoid different readings because of the cables, I'm using always the same cable. Okay, so this power supply can go up to 60 volts. I'm going halfway right now, like 30 volts. Let's see what we got there. 29.993, very good also. Let's see on the Keysight what we have. 30.007, very nice also. And 30.007 also on the Hewlett Packard. So I think this is a spot on also. My Siglant seems to be a bit off, and I will take it basically to the 60 volts. That is the maximum. Let's see what we got here. So we have 60.018, yeah, more or less stabilized there. And on the Keysight 60.021, very nice also. And on the Siglant 4.5 digits, we have 59.996 rounded to 60. Yeah, so a small difference also, nothing serious. So pretty happy with the accuracy of this power supply, and it seems that it has a very stable voltage. I will now test it using my DC electronic load. On the screen you have a new item here on the channel. It's the ITECH ET5410A+. This is a DC electronic load that is able to go up to 40 amps with 400 watts and also from 0 to 150 volts. I'm using this one instead of my Corad because this one is able to go over the 150 watts that my Corad supports, and since this power supply can go up to 180 watts, I will use this one. I'm almost sure that it's not as precise as the Corad, so give him some error margin, but it will do the job for what is needed. So let's start by testing the voltage, and I have already the electronic loads with 1 volt. We can see that is inputting 61.03 volts. That's basically more or less what is outputting from this side with 61.02. The power supply is in constant voltage, and I will also activate the constant voltage here on the DC electronic load, and let's open the channel. I will enter now the menu. Let me position this, and for 1 volt it seems that we have the 3.02 amps. It's almost the same in here, the 3.0332, but it's a little lower, and also the voltage, it's not quite the same. Well, again, I must say that I did some tests with my card, and this is much closer on the card from this voltage. Again, let's give some error margin to this is tester. Okay, so let's increase the voltage up to 10 volts. 10 volts we have 09.95. We keep having the 3.02. Seems stable that part. And okay, let's go to 20 volts. 19.96, 20.34 in the power supply. It's always a bit over and a bit under here. 30 volts, still the same. The amperage maintains. Okay, 40 volts, 50. And now the fan of the East tester started, as we can notice. And let's take it to 60 volts. This is the 180 watts that are promised here in the description of this power supply, and we are there with no loss in the amperage, so we are basically okay. Let me take this to 61 volts. I believe that it will immediately drop. Yes, so immediately it changed to constant voltage and the amperage dropped, and that is to be expected. Okay, in terms of voltage, that's it. Something that I forgot to mention is, let me close the channel. This is set to a maximum. You can see it here. Let me change to a maximum of the 3 amps that this supports. Let me take this to the maximum. Okay. Yeah, 3.083, it's the maximum amperage that it supports, while outputting the 60 volts maximum also in terms of voltage. Right now what I will do is put this in constant current, and instead of the, let me put this in voltage, instead of the 60 volts I will take it to 20 volts. Okay, that should be okay. Open the channel and let's see, take this to 8 amps is the maximum that we have here specified in the description. Okay, 8.1 amps, and I think we are okay to start. Let's open the channel of the DC electronic loads. So we have 20 volts right now at 0 amps being used. I will enter here. Let me see. Okay, let's start increasing the amperage with 1 amp. So we are outputting 1 amp, and yeah, it seems okay. Almost 20 watts. Small drop or not? Let me see. No. Yeah, it's, yeah, we have a small drop in the voltage. Let's continue to see if this is something that will maintain. Yeah. So right now we are with 2 amps, 3 amps, 4, and we are in constant voltage in this in the power supply and constant current in the DC electronic load. So 4 amps, it is 4.98 in the is tester, and it's not far also in the power supply, 4.999. yeah, okay. 6 amps, okay, still good, and we are with 7 amps. The fan started again, and 8 amps, this is the maximum in terms of amperage. Let me take this to one more, 8.1. yeah, so we are not even yet on the 180 watts. Let's increase here the voltage a bit. So I will take this to 24 volts. and yeah, need to go down a bit on the amperage. Okay, so let's see. Yeah, and again we are almost at 180 watts, so it seems to be okay. 7.68 amps pulling, and yeah, the output here is 7.69 and a half, so very near also. Okay, that's it in terms of the test with DC electronic loads. I have in this folder everything I need to install the application for controlling the ITECH power supply. So we have the power supply control software in this folder, the ITECH6700 series software. Also, we have in this folder the driver for the dongle that converts USB to serial. And I will start with this one. Let me see, it has here install, yeah. Okay, it seems pretty fast to install, or is just preparing? Okay, it's preparing, accept, next, and we are done, I believe, no? Okay, we are done. So we have the driver installed. Let's go and install the software also. The software, we have also this file to install. For what I understand, we have English, Chinese, and that should be Taiwan. I don't know, Taiwan? Okay, let's go. I will want a folder and install. Seems to be fast to install. And launch. And so now I'm going to power on the power supply. Okay, the software is loaded. Let's see what we have here. We have save data, recorder, all on, fixed output, list test, and yeah, let's start by seeing here in the device list how to add the power supply. We have this add symbol, so let's start with that. It immediately detected the device that we have. It's 14800 baud rate. COM status, no? Really? Okay. Yes, it's here. So on, off, but it doesn't seem to do anything. Okay, I think that we have to connect. Yeah. So now we are connected. It is on, and we should be able to open the output in here. Yeah, exactly. Okay. So on the screen we can see that we are outputting 1 volt. Should be, I don't have anything connected to the power supply, but should be at 1 amp, and the power also is displayed here. We have a graph of utilization. We can disable the graph, clear the status, or reset the view. Okay. So to set the voltage, we just go here and, for example, put 5 volts and press enter. Okay, and if you want to set also the amps, I want to put like 5, 6, it's okay. Okay, and that's it basically, and the voltage is set. If you took a look in the power supply with the channel open, we have the voltage set. Let me see if I change the amperage, if it'll show in the screen of the power supply. It doesn't. And we cannot use the buttons while we are working with this. So while working with the software, you are not be able to use the buttons, but that is to be expected. Most softwares doesn't allow to use the buttons while working with the devices, in this case power supply. But so that's it. Okay, so what do we have? We have here the fixed output and the list test. Let's see what is the list test. Okay, so this is for programming the several cycles in the power supply with different voltage. This will be useful, for example, for batteries or any other test that you want to set up. Let's start with 1 volt, 1 amp for like 3 seconds. Okay, and then we will pass to 5 volts and 2 amps for another 3 seconds, and 10 volts, 3 amps for another 3 seconds. Okay, oops, 3 amps. And this should be okay. So now what do? We go to run, and this will go changing the voltage as we programmed in this list. This can be done also in the keypad of the power supply, but it's a bit hard to do it. And this is on loop. We can do it also in run count. In that case, we have to stop. We should put here and say how many runs you want to do it for, how many cycles. Okay, if you don't do it and use the loop, it will be always looping through these values. Pretty simple. You can import these lists or export it for later usage. And yeah, nothing much more to say here. On the top, you have all power supplies on or off. And this is because you can have several units in here. If you notice the address, on the operation chapter, I showed how to configure the address for each individual power supply. So you have it here, and you can have several units in this tab, and you can power it all on or off, or just one individually in here. Other than this, we have also the recorder, where you can start recording the data that you have here. I did already some tests before, so we have also the save data. Let's stop it. And we have the save data with the data recorded here. Okay, that's the data that was recorded at this time. You can also export this data to a CSV if you want to use later. I believe it's only for CSV. You indicate which device, the voltage, the current, or the power. You can select which values you want to export, and the save interval, in this case 1000 milliseconds. Yeah, and I don't have much more to show you on this software. It's very simple, very intuitive. I don't know if I mentioned, but we have here the constant voltage on green when the channel is open. It will be also a sign when it's on constant current. And I think that's it. Alright, let's wrap things up with a closer look at the value, build, performance and overall user experience. First up, price. On AliExpress, the IT6700 currently lists around 210 euros. That will be around $245 for my American friends. That makes it quite competitively priced for a programmable power supply that can go up to 180 watts, 60 volts and 8 amps. I will not call it a budget power supply. I think this device is a bit on a higher range in terms of quality and performance. Moving to the construction, the IT6700 impresses with its compact metal body chassis that makes up minimal bench space. The build feels solid and well put together, no rattles or flimsy parts. The layout is thoughtful, with a bright digital panel and sturdy buttons that give tactile reassurance. The power button on the front is also a major plus for me. Regarding performance under load, its accuracy both in voltage and current was spot on throughout my tests. Even when hitting its limits, it maintained tight regulation and showed minimal drift. As for ease of use, the device is straightforward once you get it set up. The coarse and fine adjustments and CVCC auto switching make the tuning quick. That said, some features require remembering which mode A, B, C, D correspond to which function, and the manual isn't the clearest. On the topic of functions, it offers a generous feature set. CVCC modes, K-lock, memory recall, and the ability to deliver any combination of voltage and current within the 180 watts envelope. Protection circuits like the OVP and OCP are especially welcome on a benchy supply like this. Regarding software, ITECH provides optional communication modules and PC control via USB and RS232. This software is really useful for lab automation or remote testing setups and allows you not only to control several units at once, but also record and export the recorded values. So regarding my final opinion, the ITECH IT6700 strikes a compelling balance between price, precision and functionality. If you are looking for a reliable 180 watts switching power supply that can go up to 60 volts or 8 amps, it's a strong pick at this price point. It's utilitarian, accurate and packs smart features you often only find in more expensive units. And don't forget that if you are thinking about buying one, using the affiliate access links whether on the screen or in the description will help to sponsor the channel at no extra cost to you. Your support enables me to keep producing these in-depth gear reviews, so thank you for your support and sponsorship. That's it for the IT6700. Thanks for watching and don't forget to leave your questions or suggestions for my next gear deep dive in the comments. I really appreciate your company and I hope to see you in my next video. Until then, take care.